Welcome to a new video on my home automation and Node-RED series. And this time I'm going to actually be talking about Node-RED because I haven't done a lot of video about Node-RED probably for a good half a year. And in one of my latest videos when I was talking about how you can change the Blitzwolf SHP power meter sockets to Tasmota, I also mentioned that I'm going to do something about power management and power logging. And actually this is what I'm going to talk about now. So I put some flow together, which is, I think it's useful in terms of, monitoring your appliances and, getting stats and doing some automation about that. What I have implemented here are a couple of stuff. One thing is both in the screen and also in the flow, you are going to see pretty much everything duplicated because I have two devices and I've implemented the same logic for both of them. So I've done all the coding and the flow in a modular way. So there are blocks that you can just copy and paste to one device, and if you just have multiple devices, then you just duplicate that part of the flow. And of course you need to change a few details just to make sure that one part of the flow works for one device and the other one works for the other. First of all, what I have done is I have done these very fancy and colorful graphs, which I use to basically just visualize whatever the device is doing which is connected to that. I wanted to do this because, well, first of all, I wanted to understand how these devices work. And then some of the automations that I'm going to be using later on is just based on these data. So what is happening here is I'm getting the power consumption data from my SHP6 and also my SHP2. So my SHP6 was connected to the fridge up until I think sort of like yesterday when I moved it here for the testing. So at the moment it's connected to a small fan, and the SHP2 is connected to my washing machine, which is not showing any activity now because the washing machine is not running. So this graph logs data, but not only that it logs the consumption data, but I also have a flow which actually also do some calculation with it. So if you remember my previous video, I set up both of my devices so they send power measurement data every 2 seconds. And what I do here is I'm not using the raw data, but I'm aggregating it to, let's say in these two examples, I think half a minute or 15 seconds, or I think 15 seconds chunks. So instead of just displaying the raw data every 15 seconds, I collect all the readings and I calculate the maximum, the minimum, and the average power consumption. In this example, I'm not worried about the the voltage and the amps, so I'm only looking at power consumption. And I'm using this because I think based on what sort of device you're using, sometimes the average and the maximum can be quite different. And I think this is also good to see if there are any really short-term peaks in your device, which I don't know, you need to cater for, or that can indicate some sort of problem with the device. But I think in general, especially if you have devices where maybe it gets a spike. If, for example, there is a pump which might have a sudden spike when it starts moving, but once it starts, let's say, pumping water, then it settles to a more average consumption. So with this aggregation functionality, I think by looking at the average and then acting on the average consumption, it's you probably can eliminate some of the the false alarms or the the false positives when you have a sudden spike. So here I'm getting two graphs for both of the devices, and so I'm getting each graph is set up so it holds 500 data points. So that's basically 500 times I think 15 seconds in my case. So you can see that it sort of like covers 2 hours. And I also wanted to save how these graphs. So what I have done, I've also created a save functionality. Oh, by the way, you can set the aggregation period here, so you can set it to, I think for me it's set to 15 seconds at the moment. And so, for example, I have this, which is it's, well, nothing is connected at the moment. So I think it's probably reading its own, power usage or something like that. And then previously these sort of readings that you see here is the power supply of my laptop. So if I want to save this, what I can do is I can put a name in it and I can say I want to save this chart. And you get a message that the chart will be saved when the next update comes around. So we just wait for 15 seconds and we should get another message that, yeah, the chart is saved. Because I wanted to see some of these data later on. So I saved a few charts, and so you can just recall them later on. So for example, this is how a washing cycle looks on my washing machine. So it's quite interesting to see that it really uses almost no power when it's sort of like in standby mode. This is one of these new washing machines where it's still powered. You just press a button to wake it up. And when it starts washing, as you can see, in most cases there is hardly any power used. It's probably just the motor turning and the valves opening, and that's probably the period when the heater is on. So it heats up the water, and after that it's pretty much nothing. Maybe these small spikes here are the ones that are maybe it's pumping the water out, or it's doing the what do you call it when it spins up at the end. So that probably uses more power, like you see 300 watts, 276 watts. And once it completes, then the power pretty much drops down to, back to zero. So for example, I was using this chart to set up an automation for myself to tell me when the washing has completed. And it's a very simple flow, because all it's doing is it's looking for this transition when the usage suddenly goes above, let's say, 1000 watts, because that's, well, definitely when the machine is running because the heater is on. And then I'm waiting all the way until the consumption drops back down to zero. And that should be the end of the washing cycle, and I get a message on my Telegram account. And I have to say it's working very reliably. And that's basically the same logic that I've used when the Blitzwolf was still on the TUI app. So I was just looking for the the high usage, and after that I was looking for the really low, like below 1 watt usage, and that works just fine for my washing machine. Works fine in Node-RED as well. So you can save the charts from any of the logs, and then basically it saves the chart. The dashboard UI chart has an output that you can just send it onto a file. Well, it's basically the chart output is a JSON, and I save it to a file, and I just load that same JSON file from the sort of the SD card of the Pi which is running on. So it's actually saved in files, and I'm just reloading the data from the file. So this is how a washing cycle looked like. This was when I started connecting to my fridge. So it just, like, as you can see, about an hour from our data, from 1 hour of data from the fridge. And if I look at the fridge, a full 500 data point cycle, as you would normally expect, it's idle, and then when it needs to cool down the fridge, then it sort of the power jumps up, and then it goes down again and jumps up, and then down again and up. So I guess there is a regular cycle, and then if you open the door more, then these high usage cycle will just get longer, because it needs to cool down the fridge a lot more. And that's just the laptop one that I saved. So I think it's a good sort of like analytical function and sort of monitoring function to see what is going on for that particular device. And then here on the side, I actually reused one of my earlier flow, which I was using. I created probably about a year ago, and I'm using this to monitor my rainfall. And the way this flow works is that I'm getting the sort of millimeters of rainfall, which is continuously being detected, so it's like an ever-growing number. And then every hour, every day, every week, I just calculate the difference. So I get an hourly consumption chart where I can see the usage every hour. As I said, because this unit was disconnected for the past day, it's not really showing everything in hours, but as you can see what the daily usage was. I'm not sure why we have a gap here. And again, this flow is only running for about less than 2 weeks, so I only have one data for weekly. So it uses 14 kilowatt hours a week. That's my fridge. And I have the same for the washing machine. Again, we haven't used the washing machine today, so there is nothing in the hourly. And in the daily, you can see that we have different height of graph. So, and probably from this, you might be able to tell how many washes we did every day. So maybe this was like 1 wash on Friday, 1 on Saturday, maybe 2 on Sunday, and maybe could be 4 on Tuesday. I'm not really sure. And again, you have the monthly. So that's the visual part of it. But let's head over to the actual flow. And I think this flow is going to be a little bit daunting if you're just going to look at it for the first time. But it's not that bad, mostly because almost everything is duplicated here. So if I look at this part here, that's doing the this. So the logging of one of the temperature, one of the Blitzwolf, the SHP6, for example. And this part is doing almost exactly the same for the other one, for the washing machine. There are a few other things here which I've added, so I get the the notification. And that part is the one which reads the logs from the file, and then basically loads them up again into this save charts section. And then I have again the flow, which is, as I said, almost exactly the same as the water metering. So I just renamed it to power metering. So this does the power metering and all the charts and calculation for one of the device, and this does it for the other one. And the rest of the flow here is just about just general automation stuff, like how you can set it up so it turns off if the consumption goes over 1 kilowatt hour. So I'm just going to talk about this a little bit later. So let me start from the top. And as I said in the beginning, I'm just going to keep it short, just to describe the the very details that you need to understand it, and in order to set up the same flow for yourself. So obviously the most important thing is to get the data in. So because we are talking about Tasmota, I'm just using the status 8 messages to get the consumption data from the sensor. So stat/shp6, I called one of my devices shp6/status8, and this comes as a JSON, so I'm converting it directly to JSON, and this goes into this aggregation node, and this does all the calculation and everything. And as you can see, this node, let me just zoom in a little bit. This node has 4 outputs. I've also named the outputs. So this is the all the aggregated data in an object. Let me just delete this. So if you need all the data that you can get in an object format here. And here we have 3 more outputs. One is outputting the minimum value, the other one is the maximum, and the third one is the average. Of course, you are getting an output every, well, in my case, it's 15 seconds. So every time one of the aggregation cycle completes. So you can see now that it's set to 15 seconds. So far I got, this time 1 reading, 2 readings, 3 readings. So it comes every 2 seconds or so. So in my case, it uses, 6 or 7 readings in one cycle, and that gets aggregated, and the max and the minimum of that gets calculated. So the output, as I said, the top one contains this object which says min, max, average, and then you get the individual one in the other 4 outputs, sorry, the other 3 outputs, and I drive them or just send them directly to my chart. And of course, I've set up the chart that it has 3 different colors. So there's one color for the mid, the max, and the average. And that's why you are seeing the 3 different lines in the line chart. Like here, all the charts are set up in the same way. And I've configured that it only holds 500 points. So once 500 points reached, then the top one will get dropped off as the new data arrives. This aggregation function has 3 inputs. There is one input which just does housekeeping, so it just creates an update, so sort of like a recalculation every second. You can also set the aggregation period, so 5, 10. I just set up a couple of examples. Just like with many of the flows, the way I'm telling whether I'm getting some setup data or some actual measurement data is that I'm using a specific topic. So these has a specific topic which is called the aggregation, and this has a specific topic which is called the update. So those things must be kept. So the output goes into a chart. Yeah, you can reset the chart. This is just a function which reloads the chart in case your node-red reloads. I have this element count. Again, it's just showing how many elements you have in the chart. And also the chart gets dumped every time it is updated. And if you want to save the chart, then that's the piece of functionality which is responsible for that. So you specify the file name, you press the save button, and then it just saves the data in the context. And when the next data comes in, it triggers this output, which actually sends the data to your hard drive. And I'm specifying the path here, so /home/pi/charts. So I've created the charts folder, and then all these stats will get saved as par underscore and whatever name that you have provided .dump. So if you want to use a different folder, then you can change it here. And once it gets done, it goes into the function done here, which updates this drop down with the sort of the files that you have created. Why is it missing the one that I've just created? Oh, and by the way, you can also delete one if you don't need. So that's one of the power measurement and calculation flow bit. And if you want to use it, there is actually two things that you need to remember. Well, actually, there's only one thing that you need to remember here, which is, let me just find it because it's not right in the top of the code, which is here. So I've also put a comment here. Change this if your input message contains the data in a different in a different field or object. So again, I'm using Tasmota. So the status 8 message, which comes through the payload, so the power is in status sns.energy.power. So again, if you have a different device which sends the data in a different way, you need to update this part here. But everything else in the code is self-sustained, so you don't need to change anything else. And again, if you copy it to use it for another device, and if it's also a Tasmota device, then there is no, nothing needs to be changed here. Let me zoom out a little. Of course, here when I'm saving the chart, I specify again the dump here. So these four nodes here are only to save your power logging in case the node-red restarts. If you just leave them alone, that means that when your node-red restarts, then it will start with an empty chart, which I think, actually, you know what? I think it makes more sense. So I'm just going to remove it from here. Okay, that was too much talking. So that's fine. And you can reset the chart anytime you want. And I think I put the reset, I put the reset one here as well. So okay, that's one reset. And then once you wait 15 minutes, then the first data will come through. Good. So the second part of the flow, which is this one, is exactly the same as the first part, with a few additions here. But as you can see, it's the input is a different MQTT node. So my other device is called SHP2. So it's stats/SHP2/status8. And the aggregation function is exactly the same as the one above. So there is no need to make any changes. And in fact, there is no need to make any changes on any of the other functions. So it just works. So the things that I've added here is this bit here. So as you can see on the top one, it just goes into a debug. And here we go into a different sets of node. And that's the one which is looking for my washing machine state. And everything is basically handed here, which says washing state. And so the idea behind this code is that it is looking for a point where the power consumption goes above a certain threshold, which in my case is 1500, so that's 1500 watts. And then it looks, once it is, and that's considered that the device is now on, and then after that it's looking for the off threshold. So it's looking for a value that the power consumption drops below 2. So if it goes below 2 watts after it's been above 1500 watts, then I consider the device to be off. So that's when my washing is completed. And actually you can see here in the code that I'm actually using the average values, which means that, you know, any sudden peaks will get discarded, but that also means that the action is a slightly bit delayed. So, you know, your washing machine might complete and you only get the message, in my case, let's say 15 seconds after, when the average consumption on the next aggregation drops to like a very low value. But I think that's fine. I mean, for me, it's definitely fine. So you can see the state here as well. So it shows whether the state is on and off. And once the device is off, then it's going to send out a payload which says the topic will be state and the payload is going to be 0. And in my particular case, I've also put a switch here. So, you know, if this is off, so the device got off, then I send a message to myself, and I'm using Telegram for most of my messages. But you can do whatever you want here. I mean, this is one of my Telegram flow, which I've discussed in one of my, you know, really early videos, probably 2 years ago. So here you get a message which has a payload 0, so you can do whatever you want here. You can send an email or text message or, yeah, whatever integration that you're using. And this flow here, I was just playing around. It just shows you how long the device was on in seconds last time. So that's the difference between the two flows. Finally, not finally, so the next bit is the one which does the, you know, saving the file. I think I don't need this anymore. And for this, I was using a special node which I haven't used anywhere before, and that's called FS. So node-red-contrib-fs. And what this node does is you point it to a folder, so /home/by/charts, and I'm telling it to give me everything which starts with power_star.dump. So these are the files that I've created. And it just gives me all the files. So from that, I can build up the file list, which is here. And, you know, once you select it, then basically that loads into the chart. So I just, you know, open up the file and then just put it into the chart and it displays. And then, you know, this last part is the one for the deletion. Again, you can just copy this. There's no need to change anything as long as you are still using the same folder to save the dump files. And yeah, it is just going to work. And I have these links in and out so that whenever you save something, that it immediately updates the file list and then, you know, it shows up in the drop down. So simple. Moving on to the next part of the flow is the metering and calculating of the hourly, daily, and the weekly consumption. So again, it looks slightly bit complicated, but most of the logic is actually happening here. So this is the function which gets the data in. It also gets the hourly, daily, and the weekly updates. So basically, these are just triggers to calculate the hourly, daily, and the weekly data. And once whatever is calculated is actually comes out on the output, and it's also stored in the global. So the rest of the flow here is basically just the UI stuff. So for all of these, you are getting free data, which is this hour's consumption, today's consumption, and this week's consumption. And you're also getting a graph. And all of it is done here. And if I go into the context, and I think I put it into global, and you can see there is power fridge and there is power washing. So this is how it looks like. So it's an object and it contains a couple of arrays. So you have hourly values, which shows you the timestamp, and that's always the beginning of the day, and then it shows you the actual reading. So this is the kilowatt hour reading that comes from the device, from Tasmota. And you also have the hourly deltas calculated. So again, it's the epoch of the beginning of the hour and what was the delta delta usage in that hour. So that's, yeah, it's pretty much zero, and as we have seen on the screen. And you have the same for daily. So you have the daily values, you also have the daily delta. So again, the epoch is the beginning of the period, so that would be the beginning of the day, 0 hours, 0 minutes. And you have the power consumption for that day is 1.9 kilowatt hours. And the same for the week, but we only have one data here. While in the delta we have one data. So this is the structure which gets generated, and it gets updated every time we receive a reading, or when the daily, hourly, weekly, whatever update is running. And again, we have a couple of outputs. So we have an output which is, this outputs the structure every time the reading is updated, and this creates an output whenever the hourly is updated, and a daily and a monthly. I should have added some nice text, but I didn't. And here I'm doing I'm doing a few things for all of these. I'm storing it into my database. I'm not sure if you can use this unless you have the exact same database implemented, but at least you can see how I'm storing the data, and you can, you can change the insert values here. And this is also the bit which generates the graphs. And the reason I have this extensive code here, because I'm trying to generate these graphs nicely. So for example, if you hover over, then you can see that, let's do the hourly one. So the label for the data, let's do this. Okay, so I don't have hourly anywhere. So the label for the data actually says between which hour, you see 16 to 70, hourly consumption 0. And the same for the daily. So it was the consumption the Tuesday the 19th. So if you hover over the graph, then it gives you the data, the exact sort of x-axis value for the data, and the same for the weekly. So this is the weekly consumption for the week commencing the 18th of November. So if you need to change that in any way, you just come here. So you see, yeah, these are the 2 hours, and yeah, I'm specifying here the various days, and I'm getting the days. So DL, it gets it from this array. So if you want to make your own changes, or you want to translate it, you want to translate the days, then you do it here in these function nodes. And of course here you have the that's basically the title of the series as well, so you can update that as well. And just like previously, and the ones that I have actually deleted, is all of these graphs get saved because, well, if your node-red restarts, then pretty much your weekly is going to start from scratch, unless you have these chart dumps and reading of the dumps. So once you are implementing these, just make sure that you edit all of these, and then change the file names, because they are obviously sort of hard coded here. So this is where you specify which file to save the chart in, and here you specify pretty much the same file that you want to reread when the node-red restarts. So that would be 3 different file names here, and then the same one here as well. So just make sure that you update that. And the other thing that needs to be updated here is this very first line, actually the first couple of lines, is here you define the global variable where this data is getting stored, because you most probably want to use it in different parts of your code or your flow. So just make sure this is unique for every single device that you have. And you can also specify here how much data the code should basically keep for all of your devices. So I said that from the hourly data I store 24 hours, so that's basically 1 day, and then so 24 hourly and 10 daily and 10 weekly stats. So this graph shows 24, this 10, and that would be 10 as well once I get this flow running for 10 weeks. So that was one of the metering one. That's the other metering, and as I said, it's exactly the same. The difference is that the input is obviously a different topic because it's the SHP2. Here I have changed the name of the global variable, so it was par underscore fridge, and now it's par underscore washing. And I use the chart, the dump file, so it's washing hourly, washing weekly, washing daily. And of course, actually, I don't think I've done this one, or I might have done this, but oh yeah. So again, it depends how you want to save the data, but I'm making all these, I'm saving all these data points in one single table. So obviously I need to specify what the device is and so what the data point is. I don't want to go into the details because there was a whole separate video and there was quite a long one as well. So that's the sort of the metering and the measurement flow in a nutshell. And let's move over to the actual automation, which is probably going to be most interesting for most of you. Well, despite this code here, which I've done to identify when the washing is off, I think that's quite cool as well. So the other part of the flow here is I tried to came up with a couple of ideas how you want to monitor your device and how you want to act. And I managed to identify three different things. Let's say probably the first one that we are going to look at is if you want to switch off your device if it's running for more than a certain amount of time. For example, I was using something similar on my pump, which is filling up my cistern from the well, and I can tell how long it is, running if the well is if the cistern is completely empty, and how long it takes to fill it up. And of course, there's a float switch at the top, but what happens if the float switch gets stuck? Then your pump is running all the time, and probably your tank or whatever is overfilling. So I think it would be a good idea in some cases that you look at when your device gets turned on and then monitor how long it is running continuously, and if it's running for a certain amount of time, then you just kill it. And this is what I've implemented here. So I'm using the power topic from Tasmota, which is going to send me an update every time the device gets turned on and off, whether if I'm turning it on from here, or actually it is via a button or some other method. So that's that will give me an update every time, and it only gives an update when it's turned on and off. So I think that's ideal for me. And what I have done, I've created a function node, which also with the help of this every second inject node with an update, which actually does the calculation. So once it receives a signal, then it starts counting. So I've just turned it on with this one, and as you can see now it's counting that this unit is now running for 38 seconds. I mean, the fan is actually not running because it has its own switch, but the unit is on. And the reason I like this part of the flow, because it is relying on the status message of the Tasmota, so you can have this piece of flow completely separate from your other automation, because doesn't matter how you turn that unit on, well, this would trigger. So now it's running for 64 seconds. And I've written this function node in a way that you don't really have to understand the code in it. It's it's completely self-sustained. You can have multiple of these function nodes, and they will all function as independently. But what they do is they send out a message basically every second, which is going to tell you what the update is. And if I turn it off, then it's just going to send zeros. So it always outputs the number of seconds your device is running. So I can just create a simple change node which says if my payload is more than 3600, so that's 1 hour in seconds, then I generate I change the payload to off, which is the the standard payload for Tasmota to turn off a relay, and I say and I send that message to the command /shp6 or /device/power, which is the off topic for or the relay off topic for Tasmota. And it's as simple as that. You just use this counter and then a switch where you specify the runtime, and then yeah, you turn it off. And of course, if this time doesn't reach, then there is no message there's no message leaving the switch node, so there's nothing really happens here. So that would be my simplest flow. And the rest of the automation flow is about looking at the consumption of the device. And in these examples, I'm using the actual consumption, as in kilowatt hours, rather than the power that is being drawn by the device. Because I think we do have a lot of devices which tend to go for a peak. Like, as I said previously, you have a pump. You know, when it starts, let's say, moving fluid around, it would definitely have a peak, and then there could be other reasons why there is like a sudden surge in the beginning when you switch something on. And if your device happen to monitor that peak and you are trying to trigger on that peak, you might be getting false positives. But because I'm using this aggregation, you know, the whole function that we have discussed in the beginning, which is you know, reading multiple data and then calculating the averages, I think it would be much safer in most cases that you trigger on that one. So I have done two flows here. Is one that every time is basically this link in flow. So on the SHP6, which I have connected to the fan, I have an output from the average result. So this is giving me an average power usage every 15 seconds. And basically all I'm doing is I'm checking if the payload is greater than 25, and then I'm sending a turn off signal. So if I turn this device on, as I said, it has two power settings. So in the lower power setting, it's just drawing about like 21 watts. So we can keep this running and nothing is going to happen because the average power usage is going to be below 25. So even if I look at the graph, you see it's 18, while the average is 21. So this is going to just run fine. Okay, now it's, okay, we haven't received new data yet. So we just have to wait another, yeah, we got new data. So it's 21, or 20.4. So that's fine, nothing really happens. But what happens if I switch it up to the second gear, also to full speed? By the way, I've added this flow which shows the power ratings. So now it's 25, 27, and it hasn't been turned off yet because we still have to wait until the average raises above 25. And it happened, and the device got turned off. So again, it goes into the turn off, which changes the payload to off, and it goes to the power topic. So simple as that. And I think, again, for example, fans, motors, pumps, this is ideal. And the other thing you want to trigger on is the power consumption in a certain period. I've just created two examples, which is basically a power consumption in a single day or in the last 24 hours. Again, it really depends on how you're using the your device, because the daily consumption, it actually, you know, shows you how much power is used today, as in from 0 or 0 minutes. So if your device is running continuously, then obviously that value gets reset. So you might want to use the consumption in the last 24 hours. But I think this is also a great way to let's say turn off devices. If you have, like, for example, a heater, and you would know that in normal circumstances it only uses, I don't know, 5 kilowatt hours per day. So let's say if it goes, you know, above 5 kilowatt hours, then, you know, something has gone wrong. Or for example, the temperature switch hasn't kicked off, so it's running continuously. And you can do it based on a consumption every hour as well. So you probably can, I mean, again, just, you know, look at the, oh, sorry, not this one. And this is why I think this is this power consumption log is really useful, because, you know, you can observe your device, how it is behaving in a certain time frame. So again, going back to your, let's say, room heater or space heater example, you know that even if it's really, really cold, it's, you know, it constantly switches on and off, so it doesn't use more than, let's say, 2 kilowatt hours per day. Let's say, sorry, or 1 kilowatt hours per hour. So you can set up something which looks at the this hour, and if it's above a certain percentage, then it's going to trip. So, and all these change nodes are, well, instead of reading the actual data, they are reading this global variable. So, for example, you can do this hour. So this will trigger if the hourly consumption is above 1 kilowatt hour. So it really depends on your scenario, but I think these are quite useful, and probably these are the scenarios that will get used more. I'm looking at my recording device and it shows almost 50 minutes of raw recording, which means that even if I cut it down, it's probably going to be well over half an hour. So I don't think we have time, and I should, spend more time talking more about the details of this flow. I think I've gone into some details too much already. If there is a real need, just let me know, and I can make a different video about the going through the actual JavaScript code and then some of the details. I've placed a lot of debug. You can put some more debug if you want to understand how it works. But I think that would be it for the moment. Go into the video description where you're going to find the links to this flow, and also if you're interested in some of the other videos that I mentioned in the comment, those would be in the cards as well, so you can just go back and watch them as well. But I think that will be all for now. Thanks for watching, and hopefully see you in the next video.